Step 6 of the hypothesis testing process is finding the p-value. The p-value is the probability that your test statistic from step 5 that we calculated using the equation is due to chance. So think about it. If you're doing an experiment and you have a theory, an idea, do you want that result to be due to chance? And the answer is no. You want that probability to be as small as possible. So let's set up our how we find the p-value. Let's make a distinction. Let's first start off by finding a p-value for one tail test, and then we'll use that same logic to find the p-value for a two-tail test. So p-value for one tail test. Okay, for simplicity, we'll just do a right tail test, just because it does fairly look like the z-table, so we'll simplify the process a bit. Okay, so when we're setting up for this test, the most important part is what z-statistic we got in step 5. So for example, if we had z equals, x bar minus the mean over sigma divided by the square root of n. So this is for the one sample z-test, but it doesn't really matter. You can do this also for the two sample as well. And let's say we got a value of 2.62 as our z-statistic. So let's find what the p-value is. The first thing we do is we redraw our distribution. So here's our distribution. Here's 0. And here is our z-statistic we calculated in the previous part. This is not the critical value. This is the test statistic. So the p-value is the area here in the tail of that distribution. So to find this area, what we're going to do is first we're going to look up 2.62 on the edges of the z-table. So let's look for 2.62. So I'm going to zoom into this table. So let's find 2.62. Here's 2.6. Here's 2.62. So that area between 0 and 2.62 is 0.4956. So of course that's not yet our z-value, because that 0.4956 is in fact this region here. Okay, so the p-value that we're looking for is the area in the tail, and to find the area in the tail we would just do 0.5 minus 0.4956, and that gives us an area of 0.0044. Now, how do we know if this rejects or fails to reject the null? Well, we'll have to compare it to our alpha. So typically, the smallest alpha that we use in the beginning of our questions is a 0.01 or 1% level. And recall that whether we reject or fail to reject the null is tied with the relationship between the alpha level and the p-value. And we find that when the p-value is less than alpha, then we reject the null. So in this case, if you look at our results, our p-value is 0.0044, and our alpha is 0.01, and therefore we reject the null. Now what happens if we have a similar test except that it's a two-tail test? Let's set that up. So we have our two-tailed p-value, two-tailed test p-value. Now everything is pretty much the same as the one-tail test, except when you set up your setup for the finding of the p-value, instead of just looking at one side, you're going to be looking at both sides of the distribution. So earlier we said that we would use a z-statistic, right, from step 5, which is 2.62. So 2.62, and purely because it's a two-sided test, we also have to do the reflex of the other side of the distribution, the other 2.62, which is on the negative side. So the p-value is in fact the sum of those two parts. So we already know that the p-value, or the area on one side of the distribution, is 0.0044. So for the two-tail test, the p-value is simply 0.0044 times 2, or 0.0088. Now again, when we compare this to our alpha level, Alpha is 0.01 and P is 0.0088, and therefore p-value is still less than alpha. So even if this was a two-tailed test, we would reject the null. What about a p-value with a t-test? Let's make a simple assumption. Let's do degrees of freedom is equal to 15. Okay, and let's say that the t-statistic that we calculate in step 5 of the testing process, which we won't conduct here, let's say we got a t-statistic of 2.20. So first, let's say we're starting with a one-tailed test. Okay, so basically let's go to our t-table here and let's zoom in. So we have 15 degrees of freedom. We got 2.20 on our test statistic. So let's look for 2.20 in this range. So that's going to be somewhere between 2.131 and 2.60. So if we're looking at the one-tailed test, we would say that the p-value is between 0.01 and 0.025. So that's how we find the p-value for one-tailed test on the t-tests. Now what about if we were looking at a two-tailed test? So we'll just assume that same value. We'll just assume our degrees of freedom is 15 and our test statistic that we got in step 5 is 2.2, except in this case we're looking at a two-tailed test. So once again, let's zoom in to our t-table. So 15 degrees of freedom, once again, that 2.2 is between those two values, but in this case we're going to the row of the two-tailed test, and so in this case, notice basically it's double what we got previously, and the p-value for the two-tailed test is between 0.02 and 0.05. So hopefully this helps clarify how to find the p-value for z-tests and t-tests.